Welcome to another exciting Java class. I had a homework assignment, and I gave everybody lots of hints, and then I got a little pushback, and some people had some problems with it. And I was wondering if anyone had finished the assignment. Rich did it. All right. Anybody else? That's it? One person only? Well, that doesn't speak well for my teaching abilities. Um, um, can somebody tell me what the problem was? Yes.
For one thing, the HTML document was, in my opinion, poorly constructed. There are a lot of
Ah.
siblings and not enough parent-child relationships.
Mm-hmm.
Second of all,
Bad HTML structure.
yeah,
That's classic.
yeah,
When you're in the web, you don't find XHTML. You just find dirty HTML. That's
yeah,
typical.
I figured that it's not its fault for being dirty because we have to still get the information out of it. I just couldn't come up with an elegant solution using the JSON libraries.
Well, think of it a different way. Suppose it wasn't HTML. Suppose it was PDF. Then where would you be? I mean, a lot of times what happens is people put out a financial document. It's not even electronic. You got to scan it in. Then where would you be?
Image processing.
Image processing. It's a problem, right? You're dealing with essentially document processing, only it has an electronic form. So in some sense, we can call ourselves lucky because we don't have to type it in. Because that would stink, right? I mean, think of it a different way. And this goes to the basic motivation for why we're doing this. Faculty members at Fairfield University are very similar to faculty members across the nation. They are forced to save money into pension plans that essentially take the money and put it into baskets of stocks. So many stocks that no one human being could possibly know what they're invested in. No idea what your money is in from a day-to-day basis. And this is probably true for many of you, especially if you're invested in mutual funds. And many of us are. So as a result, we don't really know what's inside these mutual fund portfolios. So then the basic question becomes, how can we extract that data and manipulate it in order to be able to estimate the goodness of all these funds? Now, when you think about it that way, you're thinking about literally hundreds, if not tens of thousands of different combinations of stocks in these different funds. And Fidelity is probably running trillions of dollars at this point. No kidding. I mean, we see one thing, like here's one: 606,000 shares of EMC, 25,000 shares of Apple. Right? I mean, these are big numbers. Right? Apple is like a $500 a share stock. Big numbers. And this is just in one little thing they call a computer select fund. And so when we look at some of these things, we think, oh my goodness, how much of this value is available to us, and what can we extract in terms of information from all of this junk? And so when we do this kind of data mining, if we're able to find out what the real holdings are on these mutual funds, that could be significant. It has lots of impact. So there's a substantial motivation for wanting to know these things. I'm keen on seeing your solution to this, Rich. Is it on Blackboard? So if I go to Grade Center and Needs Grading, what do I find? Oh, here you are. And so can I just see your solution? How does one do that? Oh, here we go. Now, is that something I can download easily, or do I have to cut and paste it? It's a cut and paste thing?
Yeah, there's a sample output at the bottom of the website.
Oh, wow. That looks good, actually. Well, let's have a looky-loo at what you've got, and I'm keen on seeing your attempt and how you approach the problem. Let's see now. What's the name of this file here? Homework 2. And what package is it in? No, the default package. Okay. So let's do this. What we'll do is we'll create a new class, and we'll call it HW2. Okay. And then what we'll do is we'll wipe this part out, and it ended up being in the serial port class. Oh well. Let's do a paste. And I got an error in here somewhere. Oh, it's a capital. Let's refactor it to make it capital, and then we'll move it to I use F6 to move things. I'm going to move it to net.datamining. I think that's a good place for it. Actually, it's not. I don't have data mining in there. Is that under web? Might be under web, or some. I forgot where the data mining thing is. Maybe it's under finance. Oh, there it is. Data mining. Good. Refactor. So now, let's see if I can do this. Run. And now I have to go find the file. Let's play find the file. I know it's in here somewhere. There it is. I win. Okay. Open. Oh, wow. It even kept the little registration thing in there. We were having troubles with that before. How come it opens it in Notepad?
So I told it to open it in the default access.
I've never seen it do that before.
Yeah, I thought it was kind of cool.
That's very cool. I had no idea you could do that. I learned something new. So Java can tell the system to open a text file in Notepad? I love that. This looks really good. Okay, so let's look at your code and see how you did it. Close. So, you did it looks like you're using JSoup. And you made a JSoup document, and it came from OpenHTML. So let's have a looky-loo at OpenHTML. Can people see this okay in the back of the room? Marodi, are you okay with this?
Yeah.
You can see it all right? So now it says here, do a JFile chooser. So that's going to be the swing file chooser. Does a show open dialog box. And then he goes and gets the selected file and an absolute path name. Once he has the absolute path name, he comes up with working path with a substring starting at location 0 and going out to the last file separator. What's that about?
It's for the save file later on.
Oh, I see. So you're storing the path. So this is the parent. So in the way you would do that, not to be picky, but if you say main HTML dot get parent, that will give you the, I see what you're trying to do. This is how you do that. So that parent file is the containing directory. File, I'll call it parent directory. Parent dir. How's that? Parent dir. So then what you can do is you can, how shall we call it? Working path. I'll use your name. Copy. Whoops. Copy. Paste. Working path. And that should give me the same effect. We'll call that refactoring. Now it doesn't look like working path is local, so I gather it has to be here. Now what did you do here with working path? Is working path a it's a string.
Yeah.
Oh.
So I just appended it to the front of the save file.
Dot to string. Or I think I can even get the parent. There might be another way to do this if you want a string. Get parent with a string. There. So now I don't have to call it toString. How's that? Shall we try it again just to be sure? Oh, he doesn't seem to remember where he was. It's okay. So let's do this. Lion, main, whoops, open, and yeah, it seems to be working. So that's all good. So now I've got your parent. So now you can set the document to null. What's that about?
That was just to initialize it.
Okay. And then you do a JSoup parse, UTF-8, and you throw in this file, and presumably that returns the document. So now you've got a JSoup document from a file. Then you go through and you parse it in this thing called parse HTML. Parse HTML takes the JSoup document, and now you're doing this thing with the line separator again.
Yeah, that's for later on. It's for the printout.
Oh. So now you've got an array for T data. What's the T data for?
Table data.
Table data. Sure, that makes sense. Okay. And now I have an array of data. And now what is going on? Here's a file writer. You go through each element where you're selecting P. What's P? A paragraph?
Yeah.
So for every paragraph, you go and you parse out the paragraph text. Now, tell me about paragraphs. Why are they important in this document?
So I initially started with using the table data tags.
Uh-huh.
But the header information that had the portfolio name wasn't using table data tags.
I see.
But in paragraph have both the table data and the header information, so I use that instead.
Great. Okay, so you decided to group by paragraph, and within each paragraph you'd have both table headers and table data. Cool. So then you went through and you said t.size, so that would have been the number of paragraphs you found. Then you made an array, and then you cleared the array. So let's see, what are you doing here? It looks like tdata is an array list, and you took tdata and you converted it into an array, and that returns an array containing all the elements in the list in proper sequence. So the array list is an array of unknown length. ToArray gives you a immutable array, an array that is one that is of fixed length, an array of string. And so this converts to an array of string. And it looks like you've already said that this was going to be string over in here, so that works out. Then, okay, here's the interesting part. Now you're getting to the work. You want to explain to us about the regular expression you used?
Yeah, so that first one basically was to go through all the numbers and remove all the commas, because I didn't find those very useful.
Right, so this here is removing commas?
It's removing any comma that's separated by digits.
Alright, so what is this question mark less than equal sign angle bracket all about?
So it's a wildcard digit locator, what I understand.
So the meta characters are the square brackets, \\, d, arbitrary digit, and so it says here, what's this question mark less than equals?
So that's supposed to be a wildcard. So it's as many as there are in the beginning and as many as there are after.
So this says, for however many digits you find, look for those digits, a number, and then separated. It's a number followed by a comma, followed by another number of numeric elements.
Yeah.
So this says the pattern can be written as, and I mean, there's a couple of ways you can do these sorts of things. This one is interesting. A pattern can be written as an arbitrary number of digits, followed by a comma, followed by an arbitrary number of digits. You go through, you run your pattern .compile with the regular expression, and then you go through and you match your data. And when you find it, you're just stripping out the commas. If all you wanted to do was strip out commas, couldn't you have just done some sort of a string dot replace all?
But I didn't want to do it if it wasn't a number. So, like if there was
Oh, you're trying to remove the commas just from the numbers. So if somebody wrote a number like 1,00, that's when you'd want to remove the comma. I see. So remove commas for usable int values. So you're taking I don't know what you call numbers that have commas in them. I guess you call them numbers with commas. And you're turning them into numbers without commas. That's cool. And so that's what you meant by remove commas for usable int values and CSV formatting. That's very interesting. So now you're looking for numbers, and this says unlimited number of numbers, right? Digits 0 through 9. And then you group those. I don't see the compile.
So for that particular one, I just did straight up match.
Okay, so now he says if it starts with fidelity and ends with portfolio, there's that funky registered trademark in there or something. Yeah, then you've got a string that you wanted to add. So tell me about the lines that contain the term fidelity and then portfolio. Maybe we should just look at those real quick and see what they look like.
So those are all the date numbers.
So if I see something that looks like fidelity, whoops, I typed the wrong thing. Control F, Control S. Oh, Control S apparently doesn't continue this. Oh, I'm not in. I was thinking I was in Emacs. Okay, so if it starts with fidelity and ends with portfolio, this is the actual portfolio name. Fair enough. So now you've got the portfolio names identified in an array of string. And the array, it looks like you've got all of the portfolio names all at once in one pass.
So now what it does is it will do the portfolio name,
Uh-huh.
then all the quotes and the values, and then the next portfolio name, then all the quotes and the values. So it keeps them in order, and then the printout statement knows how to go through that.
Okay. And so then now to me what it looks like is you're doing a little bit of an ad hoc string matching.
Correct.
So you kind of had to really examine it. And so if it contains total or market funds or stocks or commodities or central fund or the other things, or matches your regular expression, or starts with a dollar, or contains, or starts with cost, or starts with a dash,
Those are all the things I don't want yet.
these are things you don't want. And so if it doesn't have those things, then you can add the data.
So what I noticed was that every value, like stock holding value,
Mm-hmm.
the value right before it was the company name. So I went in that type of linear progression.
So that this I-1 part would be the company name, and the I part, that would be like the amount of shares it has. So now if I look at the, let's make this a little bit larger. There. So if I look at it now, I see the actual company name, and then I see the numbers that contain commas next to it, which show me the number of shares they have in Avid, for example. So how did you know that you didn't want, for example, computer hardware?
So what it does is at first it looks at the value, like the number value,
Mm-hmm.
and then it looks back at the one before it, and if it matched any of those things that I put out, then it just ignored it and added the array.
So if it contained a percentage, would you ignore it?
So no, what it was is it looked at that particular value, right? And so the first if statement says if it's not a number, just ignore it, continue. So it's only looking for numbers, and then once it finds a number, it looks one before that and sees if it's a company name.
So I mean, this looks like a row with no with no table data,
Yep.
or one table data element.
Yeah, it won't even touch that row.
It won't touch that row. How do you skip the rows with
You go back to the other code. I'll show you. So you see all those things right there? The if statement right above that. So just yeah, that one.
this one here?
Yep.
So if data matches the regular expression, where the regular expression is 0 through 9, so it has to have numbers.
Has to just be a number.
Has to just be a number. So when I look at something like this, are you just comparing this one to see if it's just a number?
Correct.
I see. So if that's not in there, then you'd skip it. Okay. I mean, another way you could have done this is you could have looked at it and said, geez, I only care about those rows which have 3 table data elements, although this looks like it might be 4 table data elements. I think they inserted one as a space. But you could have said, if it doesn't have the right number of table data elements, skip it.
Yep.
And then you would have just focused in on those elements that you care about.
I think the only problem with that was that because I had to sort out as paragraphs before to get the table headers,
Mm-hmm.
I was already out of that type of loop where I was in that relationship.
Mm-hmm. Mm-hmm.
So it was kind of hard to figure that out later.
Right, right. If you're thinking in terms of the number of elements that are in a row, if you looked at the table parser multi, you can see the number of elements in each row right away because they're grouped by parentheses. And then in that case, it becomes obvious how many elements there are in a row, and you can just do that by counting the number of begin parens, for example. Although, in this case, there are certain elements which already have parens in them, and those would have to have been removed prior to the table parser multi, because that would confuse things. You'd need a replace string. But a replace string is an easy thing to do. All you want to do is replace parentheses. Is there any reason why you wouldn't want to take all the commas out of this? Oh, because Apple comma incorporated, sure. You might want to keep it as part of the name.
Yeah.
Although that might not be important. If you removed all the commas from this string, if you took the whole thing, main.html, and just removed all the commas all at once, how bad would that be?
It would be okay. I just didn't want to touch things that I didn't need to.
Okay, fair enough. Fair enough. I'm liking your solution. I'm just sort of, trying to think about ways in which it could be easier. But it's as complicated as it needed to be, I guess. So then you took the whole thing and you turned it into another array of string. Now you've got your print statements. So let's see what you're doing here. If you find a portfolio, you sort of begin it with some sort of header demarcation with dashes, it looks like. What's data I? Is that the portfolio name?
That's the array, your current array as well.
Say it again?
It's looping through that array.
Okay.
Which has the header information and the data for the strings.
All right. And what is output? Is that some sort of a print writer?
It's the file writer.
File writer. Okay. And then now you go through and you put the commas back in, only you're putting them between what looks like the company name and the holding. And I gather they don't have a right line, which is why you put the new line in. Now here's the interesting thing. Get desktop, edit output file. Opens the default system default text editor.
I found that one. It worked on OS 10 and Windows.
That's cool. I love that. What does it do in OS 10?
It opens
Text edit. Yeah, what else would it do? That's very cool. I'm liking your solution. I think it's not a bad way to go. It's not what I had ended up suggesting to the group. I can show you what I ended up doing. Let me see if I can bring up my HTML parser multi again. So now it's going to do a save. It's already read it. Instead of printing it out to a console, I'm having it save it, and it's going to save it to, well, let's just give it a name, foo.txt. Really? It's going to give me a hard time about this? Please answer yes or no. I don't know what I want to do. Buffers modified. Exit anyway. Yes. Yeah, leave me alone. Give me an argument. I need an argument. So now I've got this opportunity to say, hey, look, here are these things with only one element per row. Right? Communications equipment only has one element. Qualcomm has, you can see where he put in an extra table data piece that's empty in order to be able to hold the space. So it's pretty clear that there's a pattern, right? And the pattern is you need a row with 4 elements, and the first element is it seems like it's text. The second element, interestingly, is a number without those commas that you stripped out. I wonder how it did that. The third element is empty, and then the fourth element has a value. And now the value may have been estimated at the time this portfolio was filed, because the earnings per share would almost certainly have changed on a day-to-day basis, which is why we care only about the number of shares and the actual company, because at any given point in time the number of dollars per share will change, in theory. And so the way these guys are structuring this document makes it fairly clear. How do I identify the areas of interest? You know? And then there's another thing that happens, and that's kind of like the paragraph segment that you did. I have this thing called table ends. When a prior table ends, the very next thing that starts looks like it's a portfolio name. So I'm getting something of a series of select portfolios. So if I see table ends and then the next line says select something or other, I know it's a Fidelity account. So it's Fidelity Select Computers Portfolio. So it's select something portfolio. And that makes it pretty, well, it makes the parsing routine engineering, in my view. So I could probably envision a way in which to isolate only those things which have the portfolio name headers and the things that have the parentheses, and maybe there would be a lot of ad hoc special casing in this as well. Stuff with percentages in it wouldn't necessarily be seen at all, because you can see the things with the percent signs in them have only one element per row. So if I made a pass through this where I stripped out anything that has, you know, less than 4 elements in a row, I have a feeling that would do it for me, unless there is some case in here where I would be screwing up the data. I could probably strip out any row with a percentage in it, you know, a percentage point, but in general I don't see those things in any row with more than with less than I only see those things in rows with less than 4 elements. So that makes the parsing quite a bit easier. The only thing that I see here that really kind of messes me up is when they put in the parentheses in the A shares. And you could get rid of that as a pre-process. Just strip out all the parentheses in the string prior to doing the HTML parsing. And I think you can probably see that, yeah, here. He's using an awful lot of parentheses. If you stripped out all the parentheses prior to doing your processing, it would do you no harm, I think. It is true that some of the numbers are represented as negative with parentheses, However, you can never have a negative number of shares. So that will not impact you. You need to use, when you do this kind of screen scraping, a little semantic intelligence, I will call it. Somewhat semantic intelligence. Now, someone, I think Brian said, oh, this HTML really is stinky. And it's, bad, and it's not balanced, and there's lots of siblings and not enough parents, and it's not proper XML. No IDs. So how do you convert from HTML into XML? Can you do that? And the answer is yes, there are programs that do just that. And in fact, I was mucking about with, because I'm with you on this one. It wasn't proper HTML. It wasn't proper XML. So I said, well, there's a way to deal with that. And one way you can do it is you can convert from HTML to XHTML, which an XHTML is a proper XML variant where every start tag has a corresponding stop tag. And you could do that as a pre-process in your screen scraping activity. And afterwards, you could then proceed to use, I'll call them rigorous XML parsers, where rigorous XML parsers require every start tag to have a stop tag. So I did that myself because I wanted to see if I could use SACS, where SACS is a rigorous XML compiler. And what I ended up coming up with was main.xml. And here's what it looks like when it gets converted off to XML. I used a product called Interleaf, and it was able to do it. Every start paragraph now has an end paragraph. If you used a technique involving the transformation of the HTML into proper XML, then you could have gone straight to SACS or DOM and not worried about JSoup. And that would have been fine. Another thing you can do, if you have proper... Oh, he's giving me a complaint that the file's large. If you have proper XML, is you can use alternative transformation technologies for XML, known as XSLT. And if you read chapter 33, you'll see there is a separate subsection on XSLT which allows the transformation of XML into other forms of XML or even comma-separated values, or even HTML. Automatically, presumably without programming, although XSLT is a kind of programming language. It's not a particularly good one, and it's not one that I know very well at all. Nor, for that matter, do I know JSoup very well at all. That's quite new for me. So there are a couple of alternatives there. One thing I can say about Rich's approach is it wasn't pure JSoup. Right? You had to use regular expressions, and you were in there doing string manipulations. And at the end of the day, if you use the HTML table parser multi, or whatever the heck I was calling it, you ended up having to do the same thing. You were going to end up doing ad hoc string manipulations. And I'll tell you that my, I'll call it, tarnished career in data mining has always involved some ad hoc string manipulations, because people aren't using semantics in order to be able to isolate data commonly. Now, that's not always true. Here in the new age of XML, which is relatively new, and electronic filing, which all started in 1996, when the SEC required that all publicly traded companies, except in exigent circumstances, file electronically with the Edgar system. People started using FIX, which is all the rage in the NASDAQ area, and FIX is the financial interchange for XML. And a lot of my ex-students have gone on to become NASDAQ programmers, and they've got their software development house over in Shelton, and they use a financial interchange for XML which actually has semantics. Unfortunately, it's only for certain kinds of forms. Form 4s are done that way, which show the amount that individuals are trading. That gets filed electronically with semantics. That's proper in XML. Other kinds of forms are done that way, Form 10s. But there's still an awful lot of, I'll call it, free-form financial narrative. And this Fidelity Select portfolio is one of them. It's not done in XML. That's too bad, right? Maybe one day it will be. But until it is, we're still going to be faced with data mining problems. And I think this is one of them. Now, lest you get overly worried about not being able to crack this one because it was tough, I'm going to try and go a little bit easy with the grading because it seems like some people had some troubles. But you should have been able to make some kind of an effort. And hopefully everybody here was able to submit something. Is there anyone here who got so stuck they didn't submit anything? Couple? 3? Oh, a lot.
I wanted to submit like crap.
I didn't have a finished program, so I didn't submit.
Oh.
I couldn't figure out what I was doing.
I see. Well, I had given you the HTML parser solution, right? So that kind of thing, does give you at least a bit of a start, right?
I mean, once I read in the file, like I was telling you before, I didn't know what to do. It didn't really solve the problem. It just helped parse.
Yeah, it did a lot of the parsing for you, I thought. Where did people get stuck with this? Yeah.
So I was easily able to find all the portfolios, like type in a keyword, find that tag, find that utilities portfolio or whatever. But grabbing the table that corresponded with that portfolio was the tough part for me.
I see.
Because I couldn't point to that paragraph tag and say, hey, look for the next table element, and that's the table I want. That was the problem. I could get all the tables and do all fun things with all the tables, but to isolate one dependent on the portfolio, that's where I couldn't point at one, say that's where the portfolio is. I need to go a couple siblings down to get the table. I couldn't.
Were you in JSoup doing this?
Yeah, exactly.
I see. Was everybody trying to use JSoup? Yes? Yeah.
I did something weird. I put it into an array.
Uh-huh.
The information from your table. And I was sorting it like that. And I got it to work so that first column is output, but I couldn't access the actual values, just like the headers for the different stocks.
Huh. Well, let me ask you this. I mean, there are tables and then there are tables. Suppose I said, okay, here's, I'll try and pick one that's not too complicated. I know that I have something here. Here, right. So there's a table. So let's assume that you're presented with this HTML data, and you want to turn it into some sort of a data structure in Java, right? Forget for the moment that maybe numbers look kind of funky because they got those dollar signs in them, or that they have, decimal points. And forget for a moment that there's integers on the left side and that you might want to represent them as integers. If you just treated everything as a string, forget about the fact that there are primitive data types involved like floats or ints. How would you deal with it, right? It looks like a two-dimensional array of string. So if we just looked at this table, would we be able to extract it and turn it into a two-dimensional array of string? Yes, sir.
That's what I did, but in the table, how they have on some lines, it's just one header. There's no number. So when I was doing it, it would think the
Well, I mean, here's this interesting looking table. Not sure, but I've got like this main in here somewhere. I forgot how I did this. Oh, it says here I can make an input string from an input stream from a URL. So suppose I said to you, input stream equals u.open input stream. I guess I could have just commented this out. Just a minute. Let's remove this part. And let's pipe in this new URL, Kapowie. And now he's complaining because I need to import the class. And now, what's his problem? What's his problem?
Did you pull that main method from somewhere else? Because in mine I just have the calls the test HTML to table method.
Did I? Yeah, what I did in here, and I think I might have disseminated this out to the group, was I did a little bit of refactoring. So I think what I can do is, instead of file input stream, I can just use input stream here. And that way I can use an arbitrary input stream to do my parsing. So a file input stream is an implementor of the input stream interface, and a URL input stream is also an implementer of the input stream interface. So if I write a program that takes an arbitrary input stream, then I can get it from a file or a URL. And so what I'm kind of into doing is using polymorphism through the input stream interface, and I can say, look, I can get my input from anywhere. Similarly, if I wanted to write output to an output stream, I wouldn't necessarily have to care if the output stream was going to a socket that went out to, let's say, another machine, or if the output stream was going to a file, right? Because there are all these different ways you can implement output streams. And so by making use of polymorphism, I can create a component that just plugs into an arbitrary input stream and output stream, and I can redirect the I/O any way I like. And so by having a component that uses polymorphism, I have the moral equivalent of the Industrial Revolution of interchangeable parts. Right? This is kind of like a component, but it's software. So it's component software development. So if I run this now, I hope it can go out to the web and find the table. And because I modified my code to print it to a file, I'll give it a name. I'll call it foo.txt. And now he says it's done. And now I got to go back into foo.txt. And he's giving me a hard time now. Do I really want to reread this from the disk? Yes. And now we see, here's the table. And what were we looking for? A two-dimensional array of string, where each element in each string is associated with the parentheses. So that kind of makes things a little bit easier, right? The number of elements in each row should be the same. So here's 1, 2, 3, 4, 5, 6. Looks like there's 6 elements per row. And the total number of rows I don't know, but I have a feeling you can make a two-dimensional array out of this with relative ease, right? So the way I see it, it kind of helps out. Each table is marked with a table number, so we know when we go to the next table. So that's not too bad. It looks like there's some things going on here I don't quite understand. Like, what's that character? It looks like there's some kind of end-of-line character or, character junk that's been associated with this file. And I saw the same thing happen with funky characters that Fidelity was using for the registered trademark. The R with the circle in it. That was put in as a special character, and that came out funky too. What this stuff is, next to just to trade. Where is just to trade anyway? There it is. It's just empty. And yet he gave me this funky character in there for some reason I don't understand. So there's something going on there with the funky character, but we can kind of ignore it. Other than that, I thought it did quite a bit of work for us. So I thought that was helping. That sounds like you guys weren't too impressed by that. It's not your cup of tea. What would you have done in JSoup to have transformed this table into a two-dimensional array of string? Right? Here's your HTML. Probably there's going to be a table row, and then there's going to be table data, table data, table data. Right? So you could select in the document, you could select TR for table row, and then you'd get like an array of table data. And then you iterate through each element in the array, and that would allow you to build up your array list. What do you think of that? Is that better? I really don't know. Considering you've got your choices. The reason why I think my solution is pretty good is it makes use of something that's built into the Java API. And that is the HTML editor kit. And the HTML editor kit is capable not only of parsing HTML, it's capable of rendering HTML. So that means you can build a browser. So if we read like chapter 18 on Swing, we see there is an HTML browser that's in there. And it allows us to directly input HTML and then render it to the screen. So did you all have a chance to look at chapter 18 in Swing? Yes? Because it's it's got the HTML editor in there, and I thought with an HTML editor we have the ability to do parsing in HTML that's probably just as powerful as what JSoup does. I was trying to figure out what the I'll call it pros and cons, what the advantages of JSoup. Why is JSoup better than, let's say, the HTML editor? Because with the HTML editor, you're getting this thing called the parser callback. And remember, we talked about the inversion of control in SACS, where you provide the parser a series of actions to perform when tags are encountered. Here we see the HTML parser callback, and it's doing the same thing, only he can handle the HTML tags. And these HTML tags have been predefined for us. So when we look at these tags, right, we see there's a whole bunch of stuff. Is it a block? Is it pre-formatted? Is it a paragraph? And then there's a whole bunch of other HTML tags that have been defined. And it's not just like HTML 95, but I'm not entirely sure, from 1995, but I'm not entirely sure that it's as advanced as JSoup. I think JSoup can now handle JavaScript, cascaded style sheets, maybe other, I'll call them exotics within HTML that perhaps the HTML editor can't handle. I've never seen the HTML editor-based browser, for example, render JavaScript. Maybe there's another way to do that. I haven't really explored it. So we've got a whole ton of tags. Here's the tags that it knows about, and it's not all of them, but it's some. And it'll give us the ability to do some real sort of processing. And that comes with, right? comes with Java. It's part of the Swing package. So JSoup, if you noticed, I don't know if you noticed, you needed to change your path and include the jsoup.jar in order to be able to start using JSoup. It doesn't come with Java. Swing doesn't come with Java either if you're on a phone, right? If you're on an Android phone, you can't use Swing. But if you're on any reasonable desktop computer, I think you have Swing. Somebody told me that under 10.9 in OS 10, it didn't come with Java anymore. Is that true? Has Apple kind of like deprecated Java? It has? Really? So that's terrible. But you can still get it for the Mac, right? Yeah. But I mean, that just strikes me as bizarre and weird and controlling. But that's what Steve Jobs used to do. Now he's gone. They should leave Java alone, I think. But let me see what else we can do. We've got all the tables grouped all at once from the input stream, and then we go through and we can proceed to create the strings from those tables. You don't have to make the strings in this way. Once you've got your tables, you can make the strings any way you want. So you don't have to, concatenate up those parentheses. That was just a convenience that I put in there. So you can kind of see what I did. I didn't want it to all come out to the console. And Kyle said, well, how will we make it go out to a file? And I says to him, well, we'll just make a big string, and then we'll print it out all at once. So what I did was I made a string buffer, and then I just did an append. And then I proceeded to, get a two-dimensional array of string, and then I printed it to the string buffer with all of the extra parenthesis junk. Now I could have done that in a fairly more ad hoc way. I could have gone to each string and replaced the parentheses with nothing prior to putting in the parentheses. That would take out, all of the what do we call these things? The superfluous parentheses prior to the concatenation. Actually, the cleaner way to have done this would have been to introduce a variable. If you refactor and extract a variable, there's your string that you were trying to output, and you could have done the replace string on that right there. And if you take that string and then proceed to group it, could have done the replace string again just to wipe out the begin parenthesis and end parenthesis junk. And then when you introduce the parentheses, I think that makes it a little cleaner. Now here's where I wrote it out to a file, but I didn't have to. Right? I could have done something like this. Just printed it out to the console. And now when I run the program, right, the extraneous parentheses can be removed. But this is from the original table from my website. I think we were looking at a file input stream prior to my modification. So we can go back to the file now, and because it's an input stream, changing around the file from a URL input stream into a file input stream shouldn't bother the code any. Just gets it from a different place. And I think maybe, yeah, it got rid of all the extra parenthesis junk. Right, like when it said A shares versus B shares, that would have been in here. Those parentheses are now gone. And if you wanted, you could just make it so that it's only going to output the string if it contains the left parenthesis, right parenthesis, or if it's null, if it's got the null. Or you could get rid of all those extra parentheses, maybe just replace them with commas. Is that better? I don't know. So I thought you were very close to a solution with this. Some people, I guess, didn't like my my approach. What was wrong with my approach?
I just didn't know how to do anything.
Didn't know how to do anything?
I didn't know how to do it at all.
Oh.
And I'm still a little lost, to be honest.
You're still lost?
Yes.
Which part of what I did here today are you lost on?
It's comes next. It's confusing.
How can I get at the source of the confusion?
I'm somewhat confused with string abilities. Still, like, I can't picture.
Okay. Is this two-dimensional array of strings, is that confusing? Should I'm not sure what I can do to help here. Would it make sense to have sort of like a discussion about like arrays in Java? I beg your pardon?
It will help me.
It would help. Well, I'm perfectly happy to do that. I mean, there's I guess I had this arrays and vectors in Chapter 8, and we kind of went fast through it. You've had a basic class in Java, so you guys know what an array is and what a vector is?
I've only done one-dimensional arrays.
You've only done one-dimensional arrays?
Yes.
Oh, well, arrays are containers that can be containers of arbitrary reference data types. So first question is, what's a reference data type?
As opposed to a primitive data type, it holds a reference to an object.
Yeah, it is, I'll call it an address to something in memory. We don't use pointers in Java, we call them references. Arrays typically know their own length, so do vectors. They can be used to hold primitive data types, but what would you do to an array if you wanted to put primitive data types into it? For example, suppose you wanted an array of int. What would you do?
Make it int array.
How would you make, well, suppose you wanted to use an array of reference data types to hold an array of int. Suppose it was an array of object.
Yeah, just object. Make it an object array.
So suppose I have an array of object, how would I put the ints in there?
Treat them like objects.
So how would you...
They have the reference types instead of...
Yeah, you have to use the wrapper, right? The wrapper types. So you promote them to classes by making a new instance of the integer and passing the int in. And then you'd be able to put them into something like vectors if you wanted. So I can put primitive data types into arrays of primitive data types. I can also put primitive data types into vectors if I wrapper the primitive data types with wrapper classes. So here's an int array, one-dimensional. Here's an array of reference data types, which is got Tom, Dick, and Harry in it. Here's a nice array of int, which is being used to sum all the elements in the array. And here, Kyle, is your two-dimensional arrays. And I wonder if you guys have had the discussion about row major versus column major. Yes? No? Well, if you know that something is being stored in what's called column major, what you want to do is you want to iterate through columns more quickly than you iterate through rows. So you might go left to right to iterate through the columns, and then top to bottom to iterate through the rows. So in order to go from left to right, you might have a little for loop, and then to go from top to bottom, you would have an outer for loop. And so what's known as a doubly nested for loop would require that you go left to right first, and then go to the next row, going from top to bottom. So that might be called scan line order if you were dealing with pixels, going from left to right and then top to bottom. Now, if you are in column major order, what that means is going left to right and top to bottom. It means you're going through memory sequentially in the computer. This is so important because what the computer does is it goes through what's known as a four-stage von Neumann style pipeline. It does an instruction fetch, an instruction decode, an instruction execute, and then an instruction store. And that instruction fetch has to be prefetched from main memory and put into a special place in the CPU called the computer cache. So when you, as a programmer, want to access a whole bunch of memory, a whole bunch of data which is stored in memory sequentially, it's very important for you to write an efficient program that goes through the memory sequentially so that prefetches can extract the data. If instead what you do is you go in row major order when things are stored in column major, you'll be jumping around in the address area in memory, and then all of your caches will miss, and you'll have to refill the cache each time, and you won't be able to do proper prefetching, and it'll greatly slow down your computer by like an order of magnitude. So what your goal is to determine when you have multi-dimensional arrays, two or more dimensions, your goal is to determine whether you're in row major or column major for whatever programming language you're at. And if it's like Fortran, it's exactly opposite than if it's like C. That's horrific, because instead of going left to right, top to bottom, you have to go top to bottom, left to right. And that means you have to invert the sense of the for loop. I mean, it's just a question of whether you're doing rows first or columns first on your outer. I mean, it's easy enough change to make, but if you get it wrong, it's going to kill your performance as a programmer. So that's the row major, column major discussion. I always go left to right, top to bottom, and I assume that's the way Java virtual machines are generally implemented, and that's because of my experience with them. But it's not part of the Java language specification. They won't tell you what the right order is. It's one of those things you have to find out by benchmarking. When you're iterating through doubly nested or triply nested for loops, you really want to keep track of how long each row is, and you use dot length as the member. That's one of those things you cannot set. You can read it, but you can't set it. When you make a new instance of an array, that object becomes immutable. It's final. So the length is known to the array, and you can access it when you try to extract that length. You use it in the limit for your for loop or your while loop or whatever iteration construct you're using. So this is why I have this discussion about row major versus column major. Brian, am I seeing a hand?
No.
Okay. So what I like to think about when I do these sorts of things is I like to think about image processing, because I'm an image processing kind of guy. But I also like to think about computer architecture, because when I teach computer architecture, I always teach about how you have a pipeline inside of the computer CPU. Now, in the days of yore, in the beginning, you had one instruction which you executed at a time. But they called these. I don't know if you guys are familiar with the old Apples. The PowerPC 601 had one stage instructions. You did the instruction fetch, the instruction decode, the instruction execute, and then the instruction store. And each time you did one of those things, it took one CPU clock cycle. Well, along comes the PowerPC 604, and it has a 4-stage superscalar pipeline. So while one thing is doing an instruction fetch, it's like an assembly line. The next guy is doing the instruction decode, and then the next guy is doing the instruction execute, and the third guy is doing the instruction store, and all 4 things happen in a single clock cycle, because what they're doing is they're filling up a pipeline. It's like they have an assembly line of people, and he says, okay, I don't know if you've seen I Love Lucy when they're wrapping chocolates or something, but they take the candy, right, and they take it in, and it comes in, and they wrap it up, and they give it to Ethel, and then Ethel pops it in her mouth or something, and then they move it on down to the assembly line. So what we have here is all these workers are working in tandem. When that pipeline is filled, you can basically get 4 things done at once. It's a kind of parallelism, fine-grained instruction-level parallelism. And what that enables you to do, if you can fill the pipeline and keep it filled, is it enables you to improve your throughput by a factor of 4, which is great if you can keep the pipeline filled. However, if you have a cache miss because you're not using row major order when you're supposed to, or column major order when you're supposed to, then that whole pipeline gets emptied and you have to fill it up again. That's a big deal for the CPU. You've lost a whole ton of throughput. One of the key elements when you're doing this kind of vector processing is you have a single instruction that you want to execute on multiple data. Like you want to add 1 to every element in the array. So when you're doing that sort of thing, you're in what I call the DSP mode, the SIMD mode, single instruction multiple data mode. And so when you think about computing and about how you can do it efficiently, think about the hardware and what it has to do. So here's a doubly nested array. It's being accessed in a doubly nested, two-dimensional array being accessed in a doubly nested for loop. And you can kind of see how it's printing out all the elements in the array. J is being incremented more frequently than I, and so this is going in column major orientation, right? It's doing columns first, doing the columns first. If we want to do the rows first, we get I, right? All I did, right? The difference, so I'll go back and forth. Here I is in the outermost for loop. Here I is in the innermost for loop. These 2 pieces of code are not equal, right? One of them is different from the other. Why? Because I moved the outermost for loop in. So this changes the nature of the code, so it's going row major first rather than column major. And so now when you look at it, can you see that? This is terrible. You can't see that, can you? I can see it. Is it possible to change the background here? Format background. Gradient steps? So how do I make it white? Solid fill. Color automatic. Will it do it for everything?
No, you shouldn't do that.
I don't want to do it for everything.
You don't want to do automatic. Pick white.
Color white. Close. Oh, now you can see it. That's better. So now if you see the numbers, right, it's row column 0, 0, 0, 1, 0, 2. That's all in row 0 and column 0, 1, 2. And now if you go in 0, 1, 2, you can see what happens if you go left to right, top to bottom. These are the numbers you visit, going rows, 1 row at a time. And then if you go this way, 0, 0, 1, 0, 2, 0, these are the numbers you visit going 1 column at a time. Really changes the addresses that you go and visit.
Column major means you're changing rows faster.
Row major is you're going 1 row at a time. Column major means you're going 1 column at a time. Did I get it backwards before?
No, I just...
Yeah, I can sometimes get those backwards. Column major means columns you go in column order. Row major means you go in row order.
So in row major you iterate the columns more
Yes, you go across the column, stay within the row. So then comes this container which has got an unlimited number of elements in it called the vector, and they're all reference data types that are inside the vector. It has flexible size. Arrays have fixed size, and you can go from an array into a an array into a vector, or go from a vector into an array. You can convert from one to the other. Now the question becomes, what's the advantage of using vectors over, let's say, an array list? Now, Rich, you used an array list in your code, and I think you even put a template type down for string. So what's the advantage there? You had strong typing.
The array list was because I wasn't sure how many elements I was going to have.
But also the fact that you were able to identify every element that is supposed to go into your array list as a string meant you were protecting the type of the input. Everything that went into the array list was going to be a string, and anytime you tried to add something to the array list that was not a string, the compiler would complain to you, right? And so that's very cool. Here in the vector land, you put whatever you want to in there. You can mix it up. You could have, it doesn't have to be, I'll call it, a homogeneous container of elements. So if you wanted to, in the vector, you could put in a payroll, a customer, a product, anything you want. All of that can be collected inside the vector. So maybe that's not good. What you did was far more, I'll call it, type safe. What the vector gives you is a way to store reference data in a non-type safe manner. So it's a very popular thing to do because you can do whatever you want. It's also a powerful gun, and if you shoot yourself in the foot with it, well, that's your problem. So, one could say, let's discourage the use of vectors, but on the other hand, they let you do what you want, so that's kind of nice. Vectors let you access elements very similarly to arrays, only you have to go through methods. So you say v.elementAt, and it's the same thing as going array index of and gaining access to the elements. You can go in order, just like you would for an array. Order is maintained. Instead of doing array.length, you get v.size. But other than that, they give you equivalent function. The number of elements you can add is limited only by the amount of memory available on your heap. It's only storing references. So each reference is a 32-bit address in Java virtual memory. It's not requiring that you create new instances of anything. Presumably those instances have already been created, and all you're doing is having a reference to those instances. Now, if on the other hand you want to clone the elements, it's possible to do that, but beyond the scope of this discussion. So here's a vector of customers, and now we can go and get all the customers. When they come back out, notice because we're not having an array list of customers, because it's a vector of references, you have to cast them to customer type. What happens if what you stored in there was not a customer but a payroll? And then you went through and you did a v.elementAt. The compiler doesn't care if you try and cast it to customer. Compiler's totally happy with that. Oh, sure, it's a customer. I believe you. But what happens at runtime when you try and cast payroll into customer? Any ideas? Nothing good, I'll tell you that. It's called a class cast exception at runtime. And so now what you've done is you've created a runtime error. But if you use what Rich did and use an array list that is of type customer, you have protected the input so that the output will always be of type customer. You won't have to cast it. So that's what happens when you use a type-safe thing. Arrays can be sortable, and if you have elements that know how to order themselves relative to other elements, you can sort the whole array. But you have to be able to implement some sort of sortable vector, right? And that sortable vector has to go through and decide if one element is greater than another. Well, how are you going to compare two elements that are completely different? Suppose it's apples and oranges. Are we comparing them based on their name? Are we comparing them based on their calories? Are we comparing them based on whether or not they have lots of vitamin C? I don't know. So at some level, you'll have to compare those elements if you're going to start sorting them. And that means you'll have to implement an interface upon which you will do your sorting. And that means you'll have to implement the comparable interface, which will return +1, 0, or -1, depending on whether one is greater than the other, less than the other, or equal. And so if you have comparable implemented, you can write a general purpose sorting algorithm. And that sorting algorithm can be as efficient or inefficient as you like. And it's only comparing references and moving the references around. And so that's the shtick. The question of how you implement your sortable vector is, that's kind of another matter. Certainly there's no shortage of sorting algorithms, and probably you guys know more sorting algorithms than I do, I dare say. I've got a couple of them in here. Let's see now if I got a vector example. Yeah, here's a date, and now what did I do here? I made 100 dates and threw them into this vector. Then I got element at 50 and printed it, and we know it's of type object because object is the primordial java.lang class from which all instances descend. And then what I'll do is I'll just print out that object by converting it into a string, and presumably that gives me a date. I've converted the date into a string. Now, if you said to me, gee, I don't think it's a date, I think it's a customer. Right. Alt enter. What do I have to do here? I got so many customers, I don't know which one to use. How about we use the stream-based customer? Yep, he's good with that. The compiler likes it. Right? Compiler says, it's an object. I'm casting it to customer. That's okay, you do what you want. Right? So what could possibly go wrong? Ooh, class cast exception at runtime. He doesn't know how to convert a date into a customer. Yeah, I don't either, actually. So that's a critical problem with vectors. They're not type safe. Let's see what else we can do here. So you guys never did two-dimensional arrays? Here's a two-dimensional array. What we'll do here is we'll set the main diagonal to 1, and we'll set the main diagonal by iterating through all the elements, and if x equals y, that's the main diagonal, and we'll set it equal to 1, and then I think we can print it out. Yep. Here's your main diagonal. That doesn't look right. Isn't that the secondary diagonal? Main diagonal goes left to right, right? I think I printed this out backwards. Classic. Printed it backwards. A.print. Why does that print it backwards? Oh, look at that. I went through and I got x and y going in through this way. I think I could change it around this way. How about this? How about if I do this? Y, comma, x. Will that mess everything up? That should rotate it around, right? No. That's kind of wacky. I'm not sure why I printed this out wrong. There's obviously it didn't print it right. Oh, look what it's doing here for set main diagonal. It's going x and y. It's going y first. X comma y. X comma y. I'm too close to it. You guys tell me. What's the error? If x equals y, set it equal to s. That's the main diagonal. X equals y. It's 1, 1, 2, 2, 3, 3, left to right, top to bottom, right? That's the main diagonal. How come it prints it out the other way? Oh, look what it's doing. It says minus minus. He's going backwards. Well, sure. If you're gonna start with the big number and go down to the little number, that's why it's all messed up. That's key. Right? Why did I have it print backwards? That's the real question. So if we don't want it to print backwards, maybe we can do something like this. Print utils dot print. Can you print this? Alt enter. Oh, he's not happy with that. I'll probably have to print it forwards now. So let's see. We'll start I equals 0 while I is less than I dot length, or I of 0 dot length, right? I of x dot length. I plus plus. Yeah, that'll fix it. Yeah, printing it out backwards makes it backwards. Printing it out forwards makes it forwards. Yeah, don't print it backwards. That's the moral of that story. All right, hey, I think it must be break time now, if it's not past break time. I see people getting up and walking around. How was my little lecture on two-dimensional arrays, Kyle? It was okay, huh?
Yeah.
Just all right. Just,
I'm really confused on that homework.
You're still confused on the homework. Which part of the homework are you confused on still? The whole thing.
I don't
All right.
Yeah, me too. I feel the
You
same.
too? You feel
I
the
was
same
up
way?
till 3:30
Oh, no.
last night, and I had to wake up at 8. I'm like on 4.5 hours sleep because of that homework. So
It hurt my ego.
Guilt tripping.
It hurt my ego.
It hurts your ego. I don't want to hurt your ego. So.
what you have, so I can just make sure we're on the same page.
Can you do what now?
Can you email me the text of what you have for that, just so I make sure?
For the array here?
No, for the HTML.
Oh, the HTML parser.
Yeah, just so I make sure I'm on the same page.
Yeah, we can send that out.
No, I mean like
Can we go to the bathroom?
Yeah, let's do that. All right, we'll take a break.